run your analytical queries, you decompress it, and they're continuous, so it's great cache locality, and you do all these crazy optimizations that our friends at IBM have done.
You don't decompress.
You don't have to.
You can also do a lot of operations on compressed data, and there's a ton of research about it. So it's
there
all
are
great.
some products.
So now in row stores, the situation is different. So you can take the traditional approach of B+ trees, and then if you do that, then you cache your B+ tree pages in memory, and you can kind of claim that you are also memory friendly because B tree pages have memory locality and all that stuff. The difficulty there is that you have indexes, and those are separate B trees. And then as you go and perform writes, then you still incur I/O, and once you exceed the size of your buffer pool, you also start hitting this limitations as well. Now, what a pure in-memory row store can achieve is the ability to not to maintain indexes in memory and leverage pointers that kind of point to the core data structure and to the primary index. And that gives you a few things. So the one thing it gives you is you write fewer things on disk. Obviously, every proper in-memory system still has to log on disk, otherwise you lose durability. And so you don't maintain indexes on disk, and that's why you're saving on I/O. And your transaction log is much skinnier, and you're also only doing sequential writes. And then the other thing that it gives you is kind of overall predictability, right? Because you're not blocking on I/O ever. Now, when you build your system around kind of these concepts, you are limited to the amount of RAM. So, and if you start relying on swap, your performance just drops off a cliff. And that's where scale out just magically saves you. You go and say, well, your data set is limited to the amount of RAM, but you can run hundreds of nodes. And then the curve, the economical curve of the cost of the hardware that keeps dropping is on your side. So right now, MemSQL runs clusters of hundreds of nodes, and it's still an economical solution compared to one super large Exadata box.
I can see Suds wants to jump in on some of that. That was a really good summary of a lot of different concepts, but Suds, within Pivotal's approach, specifically Jumpfire, what do you see?
I mean, in terms of what you said about column orientation and the ability to actually store that in a linear contiguous manner and perform operations efficiently on that, that's great. When it comes to row stores, I actually, go back to what Brian was saying, because typically if you have an analytic store and you're performing operations on it, no one's going to die if something bad happens. However, if you're running a transactional system, right, where you are optimized for update, right, you're expecting these updates to come through, and something goes wrong, well, somebody could die, right? And that usually is the guy running engineering. Transactional systems are hard. In terms of trying to answer the question itself, the approach that we took was partitioning obviously is now so commonplace that you can walk down to an Indian restaurant and there'll be people talking about, hey, partitioning and replication, which was different from when I got started in this business. So that means, everyone gets the fact that partitioning is a lifesaver. Things like indexes, and more importantly, for recovery, right? So that you can actually have tiered systems that you can use for recovering data efficiently when a node goes down, when a partition goes down. And those are things, not just the structures themselves, but that are being optimized for write. But the way you choose to tier your usage of memory for recovery becomes a factor in your design.
I'll jump in just briefly. I disagree that the solution is just to scale out and get, go buy more DRAM. I don't think that's an economical way to go about it. I think there's always going to be memory hierarchies because there's economics and there's greed. And we always are trying to store more data than our budgets will allow. In most of these analytics kinds of applications, what determines how far back in history you keep is what your budget is. So if you are economical with it and you don't keep everything in DRAM, but you have a memory hierarchy, you can probably keep more history and be able to do more historical analysis. So our belief is that you're always going to have that memory hierarchy, and that memory hierarchy can include disk and flash and so forth. But I think that with cache optimization, you do have to think about it a little bit differently, because we totally re-engineered our algorithms to deal with cache, because you have to worry about the very finite size of cache lines, and every time that you have a cache miss, it costs you dearly, and we're highly conscious of that. So in all of the algorithms, particularly joins and group by, we had to make sure that we knew, first of all, we'd go out and automatically detect the size of the caches so that we knew for that particular machine how big the L2 and L3 caches were. And then we engineered the algorithms to partition into chunks that will fit into the cache. That sort of thing. I'm old enough to remember when the worry was about how often you went out to disk, right? And it's a different way of thinking that now that we've moved up one level in the memory hierarchy. So it's still a memory hierarchy, but there are different considerations that you have to worry about with cache as opposed to going out to disk.
Yeah, that makes sense. Actually, I want to come to Tim just for a moment, because Oracle is interesting in that Oracle also takes an appliance-based approach a lot of the time and has built big memory machines and other systems that are designed specifically to provide massive amounts of resources. How central do you see that? Is that going to be the major part of the market, is looking then at engineered systems as an approach to solve this? I know Oracle has multiple plays on this, though. You have cloud too, you have software only. Where do you see Oracle going?
Yeah, Nick, almost any topic you pick, we probably have something going on, I'm afraid.
Hedging your bets.
Yeah. We have scale-out clustering, so we can spread all your big data across memory if that's important to you. We've got a really nice storage hierarchy that transparently moves the warm data up and the hot data even closer. We own processors. We own the Spark processors via the Sun acquisition, and we announced recently some work that we call software in silicon. We're adding co-processors into the Spark chip itself to offload processing that's real data intensive, such as in-memory query processing, decompression engines, so you can put more data in memory because you can decompress it really quick, and some security related things. So we're sort of doing things across all fronts, because the one constant in our industry is change, right? Today DRAM is faster than flash, is faster than disk. That may change in a year or two, right? We may be all talking about some other kind of memory or some other kind of storage hierarchy. And so we just know it's going to change over time. So as long as I think the system isn't hardened to one answer being correct within the architecture, then you can just adapt over time as things change.
How much is that an economics decision? Brian, I know you work with a lot of big companies. Do you see cloud being the economics answer to a lot of this? Is it always better when somebody else can buy it for you at massive scale, or do you think people want to run things in-house, and does that cause them to make decided choices around price?
Yeah, well, it's clearly important to support both. The best thing about cloud is agility, and I think we all know that, and agility is life for a lot of companies. And agility is also part of what this scale-out architecture is too. Right? So cloud, agility, and scale-out are all coming together where, what happens when my app blows up and suddenly I've got to do 1 million transactions per second? If I'm in the cloud, I can grab more machines. Is it economical to do everything in RAM and scale out? No, but if it's $2 million in funding on the line, whether my app is up or down, I'm more than happy to ship a whole bunch of money to whoever my cloud provider is. Right? So with the cloud provider guys now supporting Flash, as they all have first and second generation Flash, we're part of Google's Flash launch. These storage hierarchies, I just wanted think it's probably the same bone you might have to pick about, it's not RAM scale out. Well, with flash scale out and 20 tera, 40 tera machines that are economical, you can scale out. Most of our large customers running all of North American advertising are doing that with a 20-node cluster, right? So we've shown in Intel's labs the ability to do 2 million transactions per second off of flash, not off of RAM, where your disk network bottlenecked. So with all of that going on with flash, those storage hierarchies, the ability to do cloud, it's really that agility. And I think as a Rose store, we really appreciate having that kind of predictability and then just being able to add nodes.
Nikita, was that what you were going to jump in on before? You wanted to make a similar point for MemSQL?
Well, just to want to say that whatever Guy was saying is exactly right.
Very nice.
Yeah, but most of the stuff that he was saying was kind of related to column stores. And he was saying, well, it might not be economical to put all this stuff in RAM, and that was Brian saying that too. I think it's particularly true for analytical workloads because people just love to hoard data. And if you give them that ability to hoard data, they will. I think Hadoop is the greatest example of that, a Hadoop ecosystem in general. And hoarding data in RAM is a suicide. Well, that's why MemSQL has column stores and disk.
So you're agreeing with his disagreeing of whatever. That's good.
All right. So is it economics that is causing this big shift right now? Is it that flash is getting cheaper, that renting things through cloud is getting cheaper? Is that the major driver, or are there technology considerations that are also intrinsically like that? I guess I'm trying to get at what's causing the big change to happen right now in the industry.
Yeah, I think part of it is the economics of flash. So what happens is, in our industry, there's always a few leaders who go out there and make something cooler and better, and then a lot of other people have to catch up. So, for example, in the Indian market, we have, as a customer, Snapdeal. I won't go into the long story, but what was happening was they needed to make the front page of their app richer and richer. And they hit a lot of database problems, as one does when one is trying to move really fast and agilely. And they had to switch out one database for another simply because of that. And being able to switch into a flash system allowed them to store more data. It allowed them to do more Hadoop analytics on their backside, load that into their front-edge database, and to do so at very reasonable prices. So a lot of the ad economics, when we first started Aerospike, were about, I have to compete with Google. Google uses RAM. I'm going to try to get an edge over them by putting my data in Flash. And that's the only way I'm going to undercut Google. Otherwise, it's impossible. So there have been a lot of economic reasons for this, but still driven by the overall innovation cycle. I got to do better than the next guy. I need more data. I need more transactions. I need more personalization. How am I going to do it better than the next guy? So people looking for the edge, and often seeing that in Flash and NoSQL.
Yeah, makes sense.
The technology improvements in Flash certainly are a contributory factor. If you just take, you look at Snapdeal and what's happening in that market, the growth in volumes is just incredible. And plus that market is growing. I mean, this is exactly what we saw on Wall Street. And I can tell you a quick story on this. We had, I was working with now public reference, so we were working with JPMC at the time. And they wanted us to do an order processing system. So they said, we need to do 2,000.
Can't hear back here.
They wanted to do 2,000 orders per second, and so I would fly back to New York every other week, and I said, this is not a problem because Gem 5 can currently do about 12,000 orders per second. I mean, in terms of data volumes that we can manage. So, but I didn't know how much their volumes were going to grow, and being the engineering leader, I was like, what if their volumes go up by 6x? My product won't be able to handle it based on what I know for the single node. Okay. So I asked these guys, so why 2,000? He said, well, 2,000 is, that's all we need from your product right now. So I said, how many are you doing right now? So we do about 12 orders per second. So 2,000 was a big hedge for them, right? And for me, so I went home happy because 12,000 is a much bigger edge for me. But guess what? They blew past the 2,000 orders per second within a year, 18 months. Right? And that was simply because there was a bunch of derivatives trading that came in. Smartphones started to come in. So the volumes grew and their client list grew, and now they're dealing with like much, much higher volumes. So it's ultimately comes down to the fact that the customer wants the increase in speed and responsiveness, and that's what drives the innovation cycle.
Tim, did you have something you want to add?
Well, yeah, so since I've probably been doing in-memory databases longer than most people, I started in '97 with ×10. Operating systems were 32-bit, which meant that contiguous memory addressing was limited to 2 gigabytes, which meant we really had to look for applications where you could embed a relatively small amount of data inside an application, right? It wasn't a number of years later that 64-bit OSs became popular. Today you can buy a Intel Xeon 2-socket server with almost a terabyte of memory pretty cheaply, right? And if you can compress data 10, 15 to 1, that's a fairly decent sized database that can fit in that, right? And so certainly technology has been an enabler. But I remember many days at ×10 where we were debating, is it really an in-memory database? Because everybody says, well, databases are old. Oracle's won that battle, IBM's won that battle, et cetera, so let's call it something different, right? Because the in-memory database category wasn't very popular. We were about the only game in town. So I think one of the biggest enablers right now is SAP. I think HANA has basically created a market and opened the way for a lot of startups to do interesting things in memory and basically jump onto the in-memory database category. And so we're all basically writing a lot of things together, but the market is really opening up right now. I think the biggest problem is use cases. People are going, well, I don't quite know exactly what I'm going to do with 2 billion rows a second per core, but it sure sounds fun. So we're all kind of searching for those customers to really make it a solution for the masses, I'd say, not the top end of the pyramid.
That's a really great question. I want to come back around to. So we've built these cool technologies. What do you see as really the sweet spot for your particular database platform? What's the kind of killer app, killer use case you could build with it? Because I know a lot of people here are trying to choose what might be the right one for their environment. And I'm gonna make this dangerous and put on the other side. Would you say there's an application or an environment that you wouldn't recommend? And it's always good to be upfront about that because you don't want to have somebody get burned and say, well, if somebody up here says my application works for anything, then we're going to throw them out right now. So, what's the best and worst use case? I guess is what I'm trying to say. I don't know who wants to take that first.
I can take it.
Go ahead.
Sure. So MemSQL is great for people who want to find that edge over their competitors. So we find a lot of success in this hybrid transactional and analytical processing. We make it stupidly easy to put data in MemSQL at like record volumes, and we'll let you run reports on that real time. So now, what does it mean exactly? Like who are those people? So if you switch channels on Comcast, that goes into MemSQL, and then that data immediately is piped to like iPad apps, where you can sort your shows on the order of what is people watching right now. So when you need to kind of build this kind of technology, and you have hundreds of millions of people constantly switching channels, then MemSQL is the right fit. Risk analysis in financial markets is basically our bread and butter now. So we do a lot of that. And then in ad tech, that's where our column stores are quite popular, where companies like Aerospike and then a bunch of open source competitors of Aerospike take the serving layer. What we do is we will leverage our sorted column stores, something that I think Oracle doesn't have yet.
It begins.
Didn't I say we have everything?
Oh, but he's hybrid.
Yeah, so we leverage sorted data column stores to deliver kind of sub-second performance on hundreds of billions of data points. So ultimately, the point I want to drive is people want to get some sort of performance either over their big data or their lower latencies, and they're willing to throw hardware at the problem. And okay, so if you're willing to throw hardware at the problem, how do you do it? Well, you build distributed systems. So once you have a distributed system, then actually there's not a whole lot of them on the market, and those that are on the market, you either have analytical capabilities or you don't, and then you see which ones fit your particular use case or not. And what happens is a lot of them can benefit from MSQL.
All right, I'm going to hold you to this. What's the worst use case you've seen?
The worst use case is a traditional database application. Somebody wrote an application which has 1 million features, and every feature that Oracle provides, or SQL Server for that matter, or Postgres, which is triggers and storage procedures and partitioning and like change data tracking, and there's like 1 million things in the database. So if you take a dependency on that, you're in the world of pain if you want to port your application on some other database, particularly if you don't have to, right? If the performance characteristic of Oracle, which is, by the way, for a single box is absolutely unbelievable, is enough.
Okay. Suds, you want to go next? Best and worst use cases for Pivotal in this environment?
Sure. For the in-memory database class of products, because Pivotal actually has many different products in the analytics space, and they do a variety of things. But for the IMDb category, the sweet spot for us has been places where the customer accepts that it's actually hard to capacity plan. I mean, they expect that volumes will change once the thing goes into production, right? There's a need for low latency, predictable latency. I mean, and which means that things happen and they happen quickly, and these are small, short things. You just have many of them happen. Like for example, if you run a large query which takes 4 hours, I don't care how much memory you have, you're going to trash most of it. Right? So typically, the use cases for us have been the queries are fairly straightforward, update rates are high, and these are small transactions, and you have it is elastic scale. So that's the best use case for a product like this, and we have thousands, 1,200 plus customers using the product in very relevant ways. And then we have a customer. I'm sure all of us have that one customer. They bought the product to, I kid you not, but this is GemXT that they're using. They have a database that is 50 gigs. 50 gigs. And then they complain about the fact that you don't have the tooling that SQL Server has. And, because they don't really need the product. And what is a nice way to tell the guy that, you really don't need it? So we actually invited him over and we said, SQL Server actually has much better tools. And plus, our .NET driver did not have certain capabilities. And we nicely talked him out of using the product.
So how many people were looking to build a 50 gig database tonight? Just checking. I think you're safe. Brian, you want to jump in?
Sure. So I would say our killer app is the internet. How many of you use the internet? The internet is really built on a lot of random access of short things. And it's great. You need a front-edge row store when you're building internet applications. We were part of the NoSQL revolution, and that sets us apart from some of the folks here who do have hybrid models and also include some NoSQL, but we've been NoSQL from the ground up because that's the best way to write internet front-side applications. So take a look at Twitter. Twitter is a key value application by and large, right? I log in, I'm a person, that's my key. I have a list of friends, that list of friends is a list of keys, let me go get those. For every particular lookup, I might have to do a lot of lookups, thousands and thousands of them, but Twitter has said that they have nearly, 150 terabytes of front-edge key value stored in their application. They're not doing a lot of complicated SQL queries on the front side of their application. That's the key to scale and the key to simplicity when you're writing a really rich, personalized application. So that's where we really see a lot of our use cases. Now in ad tech, that's also personalized. They jumped on personalized. Every ad is different, and you go to a site and it's a new ad, and we all get different ads every moment. They were one of the leaders in that. We now see retailers jumping on that. We see interesting cases in telecom. We see financial services companies adapting to the internet and needing internet scale workloads for front edges of their apps. What we're really bad at is analytics. Do we have analytics? Sure, we support some analytics. We have a Hadoop connector if you want to take a quick look at your, a particular audience of your high velocity store. Sure, we can do that for you, but it's not what we're built for. Although we do have a pretty cool patent that I like about using indexes in a MapReduce framework that we got in 2011. It probably wouldn't stand up. None of my patents ever do. We're not an analytics database. We're for the internet when you just need to go find this one thing and have lists and build a great app.
Guy and Tim, I know you both have very versatile databases, but thinking specifically about BLU Acceleration or in-memory option, what would you recommend people focus or avoid?
So the Blink project originally was aimed at accelerating complex queries for analytics, and BLU is in that mold. I think our sweetest spot probably is in classical data marts and star-shaped queries. It is primarily relational. It's a SQL kind of interface. A funny thing happened though on the way to the analytics, and that is that we found that when we were doing updates, that we actually in some cases were faster. If the number of inserts, say per commit, was over about 100, we actually beat the row store. And that was largely because BLU doesn't need all the indexes that we used to have for that had to be updated as you ingested data. And so we actually are comparable with the row store if you're ingesting a significant amount of data. That sort of leads to the area where we still are working, which is if you want to do a point query. We were never intended for that, and we don't have the indexes for it, and so we're working on that, but it's not the strength. Or if you want to do where a current occurs or another sorts of SQL constructs, it's not our strong spot. But we don't have any 4-hour queries, I don't think. We had queries go down from a couple of hours to a couple of seconds, and people calling us up and saying something's wrong. This is getting done too fast.
That's a great reaction.
Yeah, it's a wonderful reaction.
It can't be working right. It took too
As a former owner of an optimizer, that's much better reaction than your optimizer picked a lousy plan.
Excellent. And Tim, thinking about 12C and in-memory options specifically.
Yeah, well, as I said before, the real goal was to enable real-time analytics against existing production databases. So no more copying data, ETLing it into a data mart that now makes it stale, and now you run your analytics against that. You just run it against the same system that you're currently taking transactions, and you do that without having to change any applications. So it's really an easy way to get into the real-time enterprise, as it's often been called. And that was our big goal, was to introduce people easily to the potential and let them kind of find their way into whatever works best for their scenario. In terms of the nightmare scenario, or I don't know if it's that bad, but as we said before, most tables today are partitioned, and people generally partition based on time, right? So the stuff that's getting inserted is going into a current partition or whatever, and usually the analytics are going against older data than that, right? Now let's say somebody wants to run real-time analytics against the latest partition in their table that's getting thousands of inserts a second. Well, one of the things we guarantee is that you'll never be running analytics against stale data, which means we've got to somehow figure out how to consistently map inserts going into a row store into a column store that's getting real-time analytics against it. That's a tough problem for all of us, right? And we all sort of solve it in similar ways, but that's kind of the scenario that wouldn't work as well as other workloads.
Great. Well, gentlemen, I applaud you for being quite candid. That's really good. Well, this is why we did not invite 5 marketers to the panel. I want to actually change tacks here a little bit. These were questions we thought would be of general interest for everybody. Hopefully you agree they're useful in understanding the different databases, the different approaches, but I'm sure there's some good questions out in the audience, and I wanted to give people a chance to chime in with some of their own. I saw a hand right here to begin, but we'll move around and try and get through. No filibusters, get your question out, and we'll try to get a quick answer.
Sure. So I think one of the best statements from Stonebreaker, and Stonebreakers had made a lot of great comments right so far. So was the whole era of one size fits all database is over, and now we see that the whole HTAP category has been introduced by Gartner, where transactional analytics together. That's basically exists. And I think MemSQL and Core DB2 BLU is basically fits in that category, whereas the other three are basically in the OLTP. Do you really think there is room for a pure analytics database and a pure transactional database, or is HTAP going to be the future of the databases?
I'll take that one on first, I guess. I heard Stonebreaker's talk. I heard a preview of it at the ICDE conference that I was running a few weeks ago in Seoul, and he got the Test of Time award, so he kind of gave us a preview of this, one size fits none. Mike is a very smart guy, and I have the very highest respect for him. But many of his statements are a little self-serving. For his career,
Many? All. Not just many, all.
It's hard to believe. But he has a few startups, and he's really good at that, and promoting them. Mike has a short memory, it seems, because we have had specialty niche markets like object-oriented databases. Are there many of those around these days? No. Oracle and Microsoft and DB2 all figured out how to incorporate object-oriented databases into them, and poof, the startups either were acquired or went away. We had XML databases. Everything was going to be in XML. Are there any XML databases around, pure XML databases? Mike sort of conveniently forgets a few of these things that says that, yes, there are niche players, but they quickly are absorbed either by acquisition or by organic development into the majors, and these specialty guys kind of go away. And I think that is going to continue. We may incorporate them in different ways. For example, in BLU, we had a whole new runtime. That's kind of a big leap. In the past, we have incorporated it into the traditional low-organized runtime. This time we said, no, we're gonna redo it because we have to make it go fast. So his model is a little different than ours, I think, and I think that Oracle and Microsoft and probably pretty soon SAP HANA will agree.
Yeah, I can take this one too, because we're HTAP database. So generally, I think Guy is right, and there is this innovation curve, right? When something new comes in, there is no. I would slightly rephrase what Stonebreaker said and say no technology fits it all. So if you say row store, they don't fit all, right? So you need column storage to run analytical workloads efficiently. And then there's XML, and again, relational model is not very good for running XML. If you translate, I don't know, X query into SQL and feed it into a standard optimizer, you will start getting horrible plans. And I know for a fact because I was building XML for SQL Server. The interesting thing about now is that people are so hungry for data that special case, special type databases really have the opportunity to break out. So in the past, we have systems like Netezza who managed to get up to 300 million revenue before IBM snapped them up. And then we had Vertica, and then we have Astrodata, and all those acquisitions happened at the time. They did not have enough time, and they did not innovate at the pace that let them break out, or they sold too early. So I think the time now is different because the world is so much more hungry for data. And in general, even though the statement is true, and given enough time, having a great database which is very, very reliable, and then moving forward and just adding more features and kind of consuming all this data workloads is great, right? And over time, it will capture all of it. But because we are so hungry for data now, this time is different, I think.
So I'd like to borrow a funny thing happened on the way to the column store. A funny thing happened on our way to being a row store, which is we have started becoming the database of choice for a lot of analytics workloads. And I didn't expect that. What's happening is, instead of writing in SQL, so how many of you have a nice visual SQL debugger where you can step through your SQL? One guy. Good. I'm sure we'd all like to know what it is. Nice. SQL Server?
So we use both NoSQL and MySQL.
So these days when you program, if you're writing something pretty fancy at the analytics layer, if you're trying to do deep machine learning or something like that, that has not yet been embedded into a database, you're probably best off working in a programming language, whatever your programming language of choice. Well, what do you want underneath it? Do you want to have to carefully outguess your optimizer? No. So having a row store underneath that supports the kind of analytics that you want and can write at your application level. In my diagram there, I sort of carefully said, your compute layer, instead of being in the database, what if your compute layer is at the app server? And you've then got a very, very fast row store. There's a certain set of analytics that work really, really, really well and that are hard to do with a column store. So we've actually found that we're picking up a bunch of analytics workloads simply being the row store that we are. So, I think we're all going to agree we're in this very interesting phase right now of convergence of these two pieces. Exactly how they are, hard to say.
Should we take another question?
Mm-hmm.
You had your hand up earlier.
There is a need right now in the market for people that